And we got it going. All right. You are in chapter 10 this week, which is system architecture, and you actually have it for the next 2 weeks. So this one will run for 2 weeks on it. Registration continues. If you have not registered for spring quarter and you're going to be coming spring quarter, you need to do that as soon as possible. The other one is if you're graduating in December or January or May, you need to apply for graduation if you have not applied yet. If you're just getting the papers, that is free, but you have to apply for all of the ones that are appropriate. In the CIST area, if you're in a degree or a diploma, you're going to qualify for several pieces of paper. Because you'll qualify for some TCCs besides your degree or diploma. And if you're in degree and you take psychology, you're also going to be eligible for the diploma. And in cyber, if you take the right courses, you actually qualify for networking also. So there's a pile of papers you could end up with, but you have to apply. If you were planning to walk this December, I'm not sure if you still can or not. You'll have to contact Missy McLean and find out if you have not applied yet, because we're down to the deadline for that. And I believe that's on December the 2nd, but I'm not sure on that one. It does cost to walk versus there's no charge for just getting them to send you the papers. They will not send you the papers, your degree, diploma, TCC, whatever, unless you actually apply for graduation. Second thing, next week, I will not be on campus on Tuesday. I will be with Leadership Walker. And for that reason, we will have this session next week on Wednesday at the same time instead of Tuesday, which is what we did in October and September, if you remember right. Because on the second Tuesday of each month, I'm running into this conflict. It won't make any difference in December. I'm not even sure if I have a session in December, because that's the end at that point, that you're finished before we get to the second Tuesday. And maybe actually I think actually y'all are actually done before the second Tuesday. Yep, because the second Tuesday would be the 14th, and y'all finish up. Last class day is actually on the 6th, and their finals are due on the 7th. Now make sure if you're in here that you post a comment or comments, preferably comments, questions, comments, etc., in the chat box to get credit for participating. So you are in chapter 10, which is systems architecture. And so they talk about the different system architectures. And on that, and about what you need to build into that. So they talk about different things to consider on that, and about that you've moved from mainframes to now large amount of PCs, although you do still have mainframes in use out there. IBM still sells a number of them, although as of tomorrow, I believe it is, IBM splits in 2 parts, and I don't think that the company that will have the name IBM anymore will be the part that builds the mainframes. If my understanding is correctly, the part that keeps the name IBM will be the one that does cloud and services, particularly cloud, and they bought Red Hat for that a few years ago. And then the other part that they're splitting out on will handle equipment and all of that other type stuff. So changes again. So as you're designing this system architecture, you do want to allow for scalability. Don't get just the machines that you need for and size of machines that you need for today. Plan on growth. You also need to consider web integration. to putting things in. Yes, racks are still very much in use out there, and you still got plenty of rack servers because they sell a lot of rack servers now. Servers that are put into the rack. You also have lots of racks sitting all over the place, holding your routers and switches. So there is definitely a use on that. They talk about legacy systems. As you're building these, looking at the system architecture, one of the things you may have to consider, particularly organizations, not new organizations, but organizations been around, about the systems you already got. Which ones are you going to keep? What are you getting rid of? Are you completely redoing the whole thing? Or are you going to keep some legacy systems, and how do they match in there? And that gets into security issues, that building your security so that all of these devices are secure. And on your legacy systems, you may have to do some workarounds to getting your security and still being able to get in them. And then, as they mentioned, you might consider how your organization will process the data. Are you doing it in a batch style or transaction online? A lot of times it is transaction online now, but there is still a lot of batch processing done too. Payrolls, when you run payroll, is normally done as a batch job, but when you enter the data into it, it's normally nowadays done as a transaction oriented process, where that used to be batch also. But so some stuff is still done batch wise, a lot of stuff's done transaction. It used to be the opposite in the past. So we have moved on that. Your portals connecting between different systems will be another important one to consider. So they talk a little bit about mainframe architecture, the PC, how that fit into the whole thing. And obviously you got lots of PCs out there, but you still got plenty of servers out there. Now you're moving some of those servers to the cloud, but you still also got servers on premises all over the place. Even places that say they're all cloud generally still do have some on-premise servers, if nothing else, to back up information they got on the cloud. And so you do have a lot of that, and so you do have servers out there too. The network evolution, they talk about how that has grown. We started off initially with local area networks and then wide area networks, and actually have had wide area networks from way on back also. So local area networks, wide area networks are not something that just came about in the 80s. There was networking was done on between computers on back to, I would say, at least the 60s, when I was working in a computer center in the 70s in college. We were doing it networked at our college. What we had was a printer and a terminal and a card reader that connected to the actual mainframe in Columbia, South Carolina, that was 100 miles away, and that we would read the cards in, the data in for the students, and then it would be processed and it would be sent back and would print out on the printer that was there local to us. So we were doing networking at that point, and we actually had terminals sitting there that we could communicate back and forth with the operators down there, and we sent messaging back and forth and everything, way before people really considered that. Client server architecture, they talk about that some, that you've got a server and you've got lots of clients attached to it, and that they are using the data off the server. So they talk about that on it, on the client servers, and give you a good bit of information about client servers. And then they talk about middleware a little bit, which is just the software that allows the devices to communicate back and forth with each other. So it's just a communication software. All of this you need to look at in terms of cost benefits. What's it going to cost you and what's the benefit? It should have more benefit than it does cost. Look at your performance, because if you're going to go across the internet, is that going to impact your performance and where you won't be able to do stuff as well as if you just got it. So they talk a little bit about the internet in terms of that and mention cloud computing. Wait a minute. Now I'm not sure which one is used the most. Which one of what's used the most? With the cost benefit, the biggest thing is that you're looking at what's your cost, and there's cost of whether you buy machines, keep them locally, whether you're using on the cloud. There's cost of using the cloud, which can be enormous cost, but it can be cheaper than buying equipment. Also, if you need to have peak times, which is why Amazon developed AWS, was they needed tons of processing there at Christmas time when people bought lots of stuff, and then the rest of the year they didn't need all that equipment. So then they went to, well, wait a minute, how about we rent this equipment out the rest of the time and then we have it when we need it? Well, in terms of those cloud providers now, there's ways to have it automatically increase and decrease as you need to maintain on that. And that's no problem. Ask when y'all have a problem with it or when you get confused. So that you want to look at all of those costs involved in it, and also look at what's this going to benefit the organization. So what's our benefits? And if you're looking at just moving to the cloud, what's it costing us now with what we got, and what will it cost us once we move to the cloud? And compare those costs and see, is the cloud a benefit or is it not a benefit? May or may not be. It depends on your organization. So, and how much you want to move to the cloud. So they talk about the impact of the internet. The cloud's a big one. The ability to connect locations together and share the same information worldwide has a big impact, so that every office knows the same information as all the others. They talk a little bit about Web 2.0, which is where you've got that additional collaboration between all these organizations using the web. And now there's even a Web 3.0, which gets into a further connectivity of devices that I was just introduced to yesterday in the training that I'm going through. Let me look up Web 3.0 again, because I remember them talking about it, and that Web 3.0 is the newest thing out there, but I don't remember what it was exactly. All right, what it says is that 2.0 said we were storing it all in central locations. 3.0 says that we're going to treat it more in a decentralized way, so it's scattered on out all over the place, and so we'll have it where it's really more needed. And the second thing is that you're going to interact with your data using artificial intelligence and machine learning. And I think that was the biggest part they were talking about, is we're going to be with Web 3.0 is dealing with a lot more artificial intelligence and machine learning. So that's a new term for you that's not in the book. So that's obviously not on the test, but be aware that there is a Web 3.0 approach being talked about now. Web 1.0, or the original web, which goes back to the mid-90s, was just putting information out there onto the internet. 2.0, we started doing the commerce and sharing and working with it all. And that dates from pretty much from about the early 2000s up till now. Because there's a lot of places still don't do commerce on the internet, but they're placing information out there on the internet. I don't do commerce on my website, but I place a lot of information for you about me and about my thoughts on stuff out there. So then they talk about, are you going to do this in-house? Are you going to develop your own programs to do it? Or what? You could buy package solutions where you go out and talk with a vendor and they sell you the machine and the software, or they're selling you the software for it all. So that's a package solution. And then service providers is another approach, and that's to get with a service provider that instead of you having the software or the hardware, and you may not have the hardware because you may be doing it on the cloud, but you still own the software, you may actually do it with a service provider where they take care of the equipment and the software completely at wherever they keep it, whether it be on the cloud or in their location. When I worked for PMSC in South Carolina, which worked with lots of insurance companies, we actually had a huge data center sitting at our location, and we kept the data for lots of insurance companies there. So we were a service provider for those insurance companies. So you do want to look at that. They come back and talk about online processing versus batch processing versus other types of processing on it versus transaction processing, which they're viewing as online processing. But online processing could also involve batch processing. And then they get into a little about the network. Those of you that have taken 2451 already have already seen this last part of the chapter. But they spend a few pages talking about the basics of networking. So they talk about the OSI model, and it's just a model of here's how networking should theoretically work. And it's a 7-layer model, and it says things should normally work in this process. We've got all kinds of protocols and programs built in to work on the different layers as the data is processed from the time somebody puts it in on their machine, and it actually goes across the network. It actually goes through a number of things of changing the data around, encrypting it, getting it prepared, finding the correct addresses, getting the address in the right formats, etc. on through. So they talk about that, talk about topologies, and so they talk about hierarchical networks, which actually you would that you don't find that very often mentioned as a network type. The next 3 is what you usually do see. Well, and the 4th one, but they throw in a hierarchical one also. But if you look at that hierarchical one, you'll notice it's actually an extended star, and that's what it's called in other books. A bus network says that all of our devices are connected off of what appears to be one single wire, and that they all drop off of it. Logically now, a lot of our networks are actually bus networks. They go into a switch, and the switch connects them all together, and it's basically a cable running through it. There's much more than that because the switch has a lot of intelligence, etc. But physically, they're star networks because each of the devices all connects back to that switch. So star networks has a central point, and all the devices connect back to that central point. An extended star, as they had it, a hierarchical, you've got stars that then connect to other stars. The ring network you won't see as much used now, but it dates from in the 80s. IBM came out with a token ring network, and it's a very complete, and you guarantee delivery of information in a ring network. Now, you won't see it in terms of a wired one anymore, which were the token ring networks, but you will see hospitals and other organizations where you've got to know the data gets back and forth. If you're laying in the ICU with a heart monitor on you, you want to make sure if your heart stops beating, the signal gets to the nursing station for them to come running to get your heart beating again. A ring network will do that for you. A bus Ethernet network does not. So what they're using there now is actually fiber networks, which are called FDDI, and they're ring networks that still work off of a token going around them, but they're doing it off fiber. So you won't normally see it as the metallic. The last one they mentioned is a mesh network, which is what the internet actually is, and that's where devices connect to multiple other devices. And so if one thing fails, the whole network can keep on going. It just got to reroute to a different way around to get from one place to another. They talk about some network devices very, very briefly that they mentioned that they are out there, that you connect your networks together with routers, and then you connect your devices together within the network with a switch. They talk some about wireless networks. To spend a little bit more time on that one, and where you've got a centralized switch or access point, and that they're all communicating back to there wirelessly. And they talk about some of the standards on that. 802.11 is one to remember about wireless. All of the wireless standards come under IEEE 802.11. Some of those others, we didn't mention numbers on them, but if you take 2451 from me, I will teach you those other numbers in there. So what they're going through in a few pages here, I spent a whole semester on, and it's hard to even get it all in a semester. So they talk about that we've gone from A to B and B was the first one that really caught on. A was more specialized for within industrial plants, etc. And then we went to G and then to N, and that we're now on AC, which allows us to reach 7 gigabit per second speeds. B gave us 10 gigabits per second, and so on up. So most things are out there as AC now, and that you are using some other approaches on that also. And AC actually allows you to run at a faster speed close up to the access point, and a slower speed at a further distance, which lets you get a bigger distance in, but also get fast speed to those that are close to it. There's continuously changing on all of that, and that we're continuously coming up with new ways on it. So they talk about some of those. Wi-Fi was originally the 10 megabits per second, but they've kept expanding the Wi-Fi definition to being whatever the latest speeds are. So Wi-Fi is a broad term now in terms of it. And once you've designed this whole thing, you've got to get your users to approve it, and you'll have to modify it and go back and make changes to it. So I have just charged through chapter 10, and I'll talk about that some more again next week if we need to. Our session next week will be on Wednesday, not Tuesday. So plan on being in here at 11 o'clock next Wednesday. Now, are there any other questions for me? Because y'all threw a few good comments and questions in there. Okay, so since there are none, I'm going to go ahead and let y'all go, and I'm going to stop the recording.